In the last lecture, we looked at the situation where we had two pieces of information about a quadratic function, a point that satisfied the function, and the vertex of the function's graph. And we found the equation, right? Quadratic equation that went through those points. In this lecture, we're going to look at the more general case. Right? We have 3 points that are on the graph, nothing particularly special about them. Right? In particular, none of them is the vertex. So, how can we handle this? Well, to do this type of question, we're going to start with just the absolute general form of a quadratic equation. Y equals ax squared plus bx plus c. And what we're going to do is we're going to substitute those 3 points one at a time into the equation. So when we put 0, 3 in there, the equation becomes 3 equals a times 0 squared plus b times 0 plus c. And this one actually comes out nice, right? The two middle terms there are just 0. So this becomes c equals 3. Excellent. There's one of our 3 parameters. So when I substitute 2, 3 and negative 1, 9 into the equation, I'm also going to put that in there as well. I'm going to replace the c with a 3. So when we put 2, 3 in, we get 3 equals a times 2 squared plus b times 2 plus that 3. Right? And then I'm going to simplify this a little bit. I'm going to subtract 3 from both sides. Right? So this is going to equal 0. And of course, 2 squared is 4. So the equation becomes 4a plus 2b equals 0. Now I'm going to do it again. Right? I'm going to put negative 1, 9 in to the equation. And we get 9 equals a times negative 1 squared plus b times negative 1 plus 3. And I'm going to do the same simplifying. I'll subtract 3 from both sides and do a little arithmetic with what's left. So this becomes a minus b equals 6. So look at what we have now. We have a system of 2 equations in 2 variables. And we know how to solve this sort of thing. So what I'm going to do here is I'm going to take that third equation, a minus b equals 6. I'm going to multiply it by 2, and I'm going to add it to this equation. The 2 b's are going to cancel. 4a plus 2a is 6a. Of course, 0 plus 2 is 12. We divide both sides by 2, and we get our by 6, and we get our a value. A is equal to 2. Now we're going to do this back substitution. I'm going to take 2, and I'm going to substitute it into that third equation for a. Becomes 2 minus b equals 6. And if I solve this for b, we get our final result, b equals negative 4. And now I have numeric values for all 3 of the parameters. Right, so I'm going to go all the way back to the beginning to that y equals ax squared plus bx plus c. I'm going to put these 3 numbers in there, and I get our final answer. Y equals 2x squared minus 4x plus 3. And one of the nice things about this, this is really easy to check. Right? Just take your 3 points, substitute them into there, and you should get a true statement all 3 times. So I will admit I chose one of the points to be nice in my example. Having the y-intercept was really convenient because it gave us the value of c right out of the gate. You may not always be that lucky. You may sometimes truly have just 3 random points, nothing special about any of them. And that's fine. This same method works. You can do the exact same thing, only instead of a system of 2 equations in 2 variables, you're going to end up with a system of 3 equations in 3 variables.